Patton, thanks for coming in today.
Thank you for having me.
Brave the wilds of Atlanta traffic.
I-85. Rolling the dice every time.
Today, but it is the 2 out of 3 national championship Georgia Bulldog territory, so it's not bad.
Right. And
I think your Longhorns are joining us in our conference next season.
We'll be there next season. We're very excited about it.
Yeah. It was, look, I love Texas football. I do love Georgia football. I'm not going to pick on my Aggie brothers, but they came in with a little bit of a swagger a number of years ago. Because there's a great tradition in Texas football, and the Aggies themselves have a great tradition. They're still limping a little bit from that first couple seasons. Now, last year, man, they played fantastic. Texas played fantastic. But the SEC is no joke.
SEC is no joke. You can never underestimate the Aggies. I'm actually thrilled to bring that rivalry back. Absolutely thrilled. We used to never miss a Thanksgiving game, and it's been however many years since we played. After having played starting back in the 1800s, so it's kind of cool to see that come back together.
Yeah, I can't wait.
I'm pumped.
Today, I am so glad you came in because we're going to talk about a lot of things. All connectivity and fiber. Here's why it's important to me. If we talk about power a lot in our industry, because if you don't have the right amount of power in a facility, it's not a data center, right? It is a warehouse, it's a shed, and so there's a constraint on power. There's increasing demands on power, so that dominates a lot of the conversation. But just equally important, as far as I'm concerned, is the connectivity to a facility. To a data center, to digital infrastructure. Because if I don't have connectivity, it's just a nice air-conditioned warehouse that's not going to connect me to the rest of the world, and then I'm not connected to the modern economy. So before we dive into some of the things I'm hearing about possible constraints and things we got to work through, which is your specialty, if you were to describe to somebody who's not familiar with the world of connectivity at all, when we think of like the modern fiber infrastructure, the way it's deployed today, when did that come about? What can you tell us about it that's led us from then till now?
No, absolutely. A little bit of a history lesson that I've learned. I was in middle school when this all happened, so it's what my bosses and
wow, shots fired. I think I was like 30. So
former mentors have told me this is how it played out. But basically, you had the Bell system that controlled communications in the 80s. That was basically a monopoly that was. The industry was deregulated around that time, gave rise to a whole bunch of new fiber companies that came out and competed, right? So you had the UUNets and the MFNs and all these new kind of competitive telcos that came out and started building fiber networks. You had a bunch of moms and pops that started companies in towns and cities across the country, started building fiber networks. So that's how the initial, I guess, build out occurred.
Right.
And it was the eve of it wasn't really the eve. It was the early days of the true kind of digital age.
Right.
Copper systems weren't going to work. We needed to start transmitting and transporting a whole lot more data.
Right.
And so we needed glass, we needed fiber.
Right.
And so that's how it all started. Everybody got very excited about it, started putting lots and lots and lots of money into it. You had Level 3, the $1 billion startup, kind of come out of nowhere in the late 90s. And then you had the bust. Right. So all that fiber's built. It was probably a little bit ahead of its time. Demand wasn't quite there. There were no iPhones. There's no social media. But you just had a tremendous amount of fiber built very quickly all over the country. Then the bust. Fiber became a really bad word. Nobody wanted to talk about fiber. Nobody wanted to invest in fiber. So you kind of had a little dark age there for, I don't know.
Can I interrupt for 1 second? I want to tell you a funny story. I was actually at UTMB. Network support, network admin for a department. Ironically, the Department of Psychiatry seemed very apropos. But anyway, I interacted with Central IT, but I was a part of Central IT. And we were having this big meeting. There must have been, I don't know, at least a couple hundred IT people in this room. And somebody made mention of dark fiber. And everybody's sort of this ripple came through. So for anybody, we had a lot of ex-military coming out of the Navy and Air Force, an IT person like me, which was like compute, storage, network, but LAN, not connectivity. And when we heard dark fiber, we were like, oh, like is that, like what does that mean? Like, and so I asked, all right, look around. We're kind of trying to figure it out. And so we kind of whispered amongst ourselves, like we thought it was like taboo fiber or something, And so we asked, he's like, what's dark fiber? unlit fiber. It's
Yes,
just
it's just-
stuff in the ground. There's nothing connected to it. It was so anticlimactic.
Yes, glass.
We just wanted it to be like some taboo thing. And also it reminds me of that same era. That would have been, the big bust. So when you talk about moving from copper to glass, that would be like, I think of it like moving from telephone lines where we were moving voice to actually moving pictures and whatever, even if it was not through the iPhones yet, it was through news groups and other things, and a little bit of gaming was starting to develop then. Nothing like what we have today. But anyway, it was this thing. But so many in that big boom, people would stand up web pages to things that just didn't exist. One of the famous one was gardentools.com. And there was nothing behind it. So we build out this infrastructure because we're just early, right? We just see that there's going to be this big thing, which they were prophetic. It came, just not as quick as they.
That's right. That's right. That's exactly right. So you had a period of time there, I don't know, mid-2000s, early 2000s, where it was just kind of quiet.
Right.
And then a couple of pretty savvy investors and thought leaders in the industry had some pretty good kind of foresight to say we should probably start rolling this up and sort of creating, just bringing these. In my old company that I worked for, that we called them fiber orphans. These kind of smaller companies that were distributed across the country. They were operating these networks. Some of them were making money. Some of them were in distress, but they were just kind of waiting for the phone to ring,
right?
And the phone did ring for somebody to come buy them and roll them up. And so you had kind of a roll up that occurred beginning in the kind of 07, 08 period, right in the middle of the recession.
Right.
Zayo led that. You had not long after that, you had Crown Castle start to buy companies and roll them together. You had others, and during that period of time, you saw the kind of what we now see as just an insatiable demand of
cat videos, more everything.
More, yeah,
right.
More cat videos faster,
right.
And so I think that's kind of, you fast forward, those companies roll up. You don't have a lot of smaller mom and pops, although they're starting to emerge again. But you have basically this national network that was mostly built in the 90s and early 2000s. You had a gap, you had a roll up, so then you mashed all these networks together. And then, sure, you've seen more investment, right? You've seen some of these household kind of fiber companies build more fiber. You're seeing the fiber to the home kind of rollout occur. You're seeing money from the government through NTIA and the BEAD program, digital equity programs, kind of building fiber out to unserved and underserved areas. So that's all still happening. But I think by and large, it's kind of that early build out is still kind of defines the fiber network, right?
Yeah, for sure.
Yep.
It's not a perfect analogy, but it reminds me of when all our GIs came back from World War II, and we were the only manufacturing power on Earth at the time, and we could not get, the demand was incredible, and we just didn't have, among other infrastructures, the inter and intrastate infrastructure. So President Eisenhower and others said, look, we got to do this as people. I need the jobs. It's, good jobs. I need, if we want to be connected at that time to the modern economy, we need to do this to supplement the railroad network and the other telecommunication things that were going on. And so you had that initial rush. And even a lot today, we're feeling the pressure of aging infrastructure.
Bridges, everything, you name it. Yeah.
That's right. And it's a lot harder to get into repairing or whatever. It costs more, or you've got traffic running over it, like the complexity of that. So now that we're here, can we talk about, there are a couple areas that have come across my radar lately. I want to start with this one, which is this idea that the infrastructure that's built today, just talking about the conduits that it runs in or whatever, is pretty full. If not full, it's pretty full. And maybe not in all segments. So there's, and please correct me, the way I think about it really, really simple. There's the short segment, so from a carrier hotel or from where the connection happens within a metropolitan area to a data center or to an enterprise, you've got that very short leg. The last mile, it's called by a lot of names. And then you've got from a data center, for example, or between metropolitan areas that are nearby, the middle mile is how I'm probably getting this wrong, but that's how I think about it. And then you've got long haul. I need to go a long distance. I'm going across the coast or I'm going across major geographic areas. And And in certainly the middle and the long area, at least various carriers that I've talked to, said, look, the routes, all that initial stuff, either the pipes are full or whatever was in there is lit. It may not be lit to its maximum capacity, but we don't have a bunch of unused stuff laying around.
That's right. Most of those long-haul middle-mile networks were also built during that time.
Right.
And the majority, not all, but the majority of the metro networks. And there's a common theme. And it's, you call it a lack of foresight, or you just call it, hey, we had a budget to meet, we had a timetable to meet, and we just built this as fast as we could, as inexpensively as we could.
Right.
It was thin count. There wasn't a lot of inventory when they built these initial networks, right? And at the time, it was, I pull a 96 count fiber through a duct. Mm-hmm. Why would anyone ever need more than 96 pairs of this dark fiber? This crazy stuff that if you light it, it's an infinite amount of capacity.
Right.
And so that's kind of how the networks were built. So you're spot on. You get to a point today where a couple of problems. One, yes, there's constraints literally with capacity. There's just no fiber left. It's all lit.
Right.
Number two, it's old. Right? I mean, and this is something we could probably talk all day about, but you have these applications. You have this optical equipment that's shooting very, very, very robust amounts of data, in by 100 gigs, 400, 800 gigs, pretty long distances. The fiber has to be pretty new. It has to be clean. It has to be contiguous. It can't be chopped up.
Right.
And so that's another big problem you have is just the age and the quality of the fiber. And the third thing is just it's not homogeneous networks. These networks were built at a time when, as they're building a more kind of fiber, kind of glass suppliers were coming in and saying, here's the next literal bright, shiny technology of fiber. Put this in your network. Put that in your network. Put this in your network.
Right.
And so now you've got 3 or 4 different fiber types that some had a pretty narrow scope as to what they could solve for when it came to optical equipment on either end. And so you have this heterogeneous network, which is a bad word in fiber.
Right.
You have it's old and it's constrained just from a simple capacity standpoint. And I think that's a problem in the long haul in the metro, obviously, because those are very long distances, multiple different jurisdictions, and it's just very complex to do that. It's true in the metro. It's very true in the metro.
The way you describe it, if this is the wrong analogy, but it seems like if I have a vehicle and it's got 4 tires, for example, and I've got a tire, on there that's technology from 1975, and then as time goes on, I add another tire that's similar, like it doesn't displace the first one, but it's much better technology, et cetera. And as I continue, so now I have unmatching tires on this vehicle, and the most I can do in any particular difficult terrain is whatever the minimum tire will let me do.
Tire,
yeah. Is that's similar?
Fair. Yeah, absolutely. Okay. Or it just doesn't work at all. You can't get out of the driveway.
Well, yeah. I remember when I was a kid, I had. I'm not going to go into any. I tell myself too many times, but I do remember a time my dad came out and I was all irritated. I had replaced a tire on a motorcycle. I was really excited, a dirt bike I was racing, that I could do this by myself. It was very hard to change tires as a kid. And what made it 10 times harder was I bought the wrong size tire and somehow bent my rim and got that thing on there, and just, anyway, disaster.
Yeah.
So let's pause. When you think about these, it's fair to say, I think, nobody imagined. It was impossible. Same thing with hard drives. I remember when I bought my first computer and it came with a 40 megabyte hard drive. And my dad's at NASA down at Mission Control. And he just laughed at me. I lived in San Antonio at the time. I was like, you're not going to believe this. I bought this computer so fast, it leaves skid marks on my desktop. And it came with a 40 megabyte hard drive. My dad's like, you'll never fill up 40 megabytes. You've lost your mind.
Yep.
And, I don't even know what my thumb drive is. I think it's the 64 gig sitting over there, or 128 gig or something like that.
That you lose under the couch, right?
Yeah. So now, fiber, if I've got a 96 strand fiber.
Yep.
That means 96 unique pieces of glass to send and receive things.
Strands, yeah.
Strands.
Which usually is lumped into pairs.
Okay.
One fiber typically doesn't do you any good. You need to send and receive.
Okay.
Yeah.
So is that 96 pairs or is it 48 pairs?
48 pair.
Okay, 48
Yeah.
pair.
And that would be kind of the old,
Sure.
yeah.
But that's what I'm talking about, sort of that initial thing.
Yeah.
And I don't want to get this is not an engineering conversation, so I don't want to get super technical. But I'm
neither.
curious, when I wouldn't do well. But anyway, when they talk about, there was I can't remember what it was, 2010, 2012, whatever, my memory escapes me. But we began putting in these appliances called DWDM, and it allowed us, if I remember correctly, I could choose different frequencies. So I could have across a pair, I suppose. Before I had to have a person. That was it. That you were the person. And later I was able to take fractions of it and divide it up because I could uniquely isolate traffic. I'm probably butchering this, but I could send traffic back and forth in these frequencies. And we were lulled into, hey, this is good. I mean, even then, that 96 pair,
No problem.
because I've got all these frequencies available to me. I can light them brighter, meaning I can get a more powerful optic card on each side of this box. Yep. And we were only concerned with the last mile, so from the data center to the carrier hotel. And I could get out of that same batch more and more services to give to my customers, more and more paths.
You just continue adding channels.
Right.
Adds bandwidth.
Right.
Same pair of fiber.
Yeah.
Absolutely. Yep. That worked for a while.
And it worked for a while.
Yep.
And then within the last year, completely independently, I've had at least two, I think three different carriers saying, look, we're getting, just like you have Moore's Law with compute power, and we don't have to dive into the details of it, but there's a thing called Shannon's limit, which is just there is only so fast we can move a packet anywhere, but on land, in terrestrial fiber, and we are reaching the edge of that. And so before, when we went to go reach for more fiber, we're at the max capacity of the components of this path. We'd go just reach for more in any of these segments, log, middle, or metro. We're getting really restricted there. So theoretical limit of Shannon's law.
So Shannon's law is something that it doesn't get thrown around all the time in kind of our day-to-day, right? Because I think what Shannon's law is getting at is that there's a theoretical limit to how much you can put on a single channel, how much you can put on a pair of fiber.
Right.
And I think they're always going to find incremental gains there. They're always going to be able to come out with a new box or a new fiber type that's going to say, hey, we can get a couple of more bits, a couple more 100 gigs, a little bit lower latency.
Right.
The problem with that is, and at least the feedback we get from our partners and customers, is costs. It is incredibly expensive to support that incremental gain. And so why not reach over and just grab another pair of fiber and put some of the tried and true optics that you've been using for the last 10 years on.
Right.
The second part is supporting it. I mean that from kind of a field standpoint. You're seeing a lot about hollow core fiber. These new types of fibers that are coming
Just got introduced to it, so
Really?
tell me more
Yeah.
about that.
So that's the theory there is that light travels faster through air than through glass.
Okay.
And so you basically have this hollow, empty air core in the fiber pair itself, which in theory can just reduce latency, add more channels, and just push a lot more, like we said earlier, lot more cat videos a lot faster on a single pair of fiber. The issue there that they're dealing with is loss, but that's a separate technical discussion. Not all the packets are showing up at the other end of the line. But the other issue is just supporting it in the field, splicing it, the type of equipment you need to repair it. They're saying that's really, honestly, like the long pole in the tent is the industry sort of catching up to something like that. So will that be a solution in 10 to 15 years? Probably. But in the next 2 to 4 to support this incredibly steep curve and demand and shortage of network in the ground, probably not. It's probably going to be we need more fiber versus kind of trying to polish up the optics or come up with some brand new technology.
Right. Well, the asterisk next to for me around Shannon's law or Shannon's limit. I have switched it to Shannon's limit. I think it's interchangeable.
Yeah.
But Shannon's law is a Florida law about some kind of something terrible happened to somebody named Shannon.
Yeah.
So Shannon's limit. Internationally, they call it Shannon's law because that's it's obviously they don't have the same context.
Yeah.
But when I talk to the engineers on the long haul in particular, they're like, the Shannon's law is coming, like it's the red coats, right? Yep. When I talk to other folks, it's like fair, Moore's law also is impacting over here in CPU world, but there's still so many other gains for us to get. The bigger challenge is, and they would say this too, they're being asked by their customers, hey, I need fiber. Give me a path from here to Chattanooga, for example, or Chattanooga over to Des Moines. I don't know why you'd go to Des Moines from Chattanooga, but give me a path. And whatever they would do in the past, there is very limited inventory. And while there are a number of projects underway, in their opinion, that's why I ask you, it doesn't feel like the volume of projects underway is matching the perceived demand, not just today, but what's coming. Yep. And it's expensive. It's not easy.
Right. Yep. I agree. I think long haul is a very unique challenge. And in that case, does it make sense to get a more expensive box versus overbuilding 400 miles of fiber through the blue granite in Appalachia? Yeah, probably.
Yeah.
And then if you reach that theoretical limit of Shannon's limit,
right.
then you're in trouble.
Yeah.
There's no doubt about it.
It's fascinating. A number of people are talking about if you take a signal, you take a packet, and you shoot it up to a satellite, it's exponentially slower than sending it down a fiber path, unless you're going a long distance. Because if you could send it up to a satellite, and as the distance gets greater, and it's shooting it through space, a vacuum, it moves at truly the speed of light. And then, it lands at another satellite and goes really slow down to its destination. But if you get a far enough distance that total trip is faster than across the ground, through a sea cable, or whatever, depending upon where you're going and what you're doing. Yep. So that's an interesting area for me. We're not here to talk about low Earth orbit or constellations or whatever. But perhaps in some of these really the Rocky Mountains or big areas of desert or whatever, that might be an area where you don't reach for a fiber. There's some other option.
Absolutely. The improvements they're making in throughput, because really it's about throughput. They can reach anywhere. It's throughput, and if they can solve that to a reasonable extent, some of those underserved areas in the U.S. and globally will benefit from that, and I hope that happens. I think that's a very logical way to solve for that.
Well, you've been very patient with me. I keep peppering you with these middle and long haul, and I'll get some middle and long haul people in here to talk. But one of the things I think is really cool with what you guys are doing is you're solving the same kinds of problems. And correct me if I'm wrong, but your focus seems to be more within a greater metropolitan area. Sure. Is that correct?
Yep.
Can you describe what the problem that you're solving there is and why? Because I think it's even more expanded than just there's enough fiber or the existing fibers troubling, new designs, just all of these sorts of things. And then I want to ask you about availability zones because if you get a chance. But anyway, what is it about the metro that you guys are trying to solve?
So kind of our I guess the way that what we believe is that metro fiber networks today simply do not meet the needs of today's digital demands.
Right.
Like it's what is demanded by the largest consumers of bandwidth in the world really doesn't exist in most of the metros. And when I say what's demanded, what do they want? What do they need? The fiber that exists today, and we talked about this already. I think it's a common theme. It's older. It's thinner count. It's aerial. And sometimes it's underground. Sometimes it's aerial. Mm-hmm. It is a patchwork of, like we talked about at the very beginning, a bunch of different legacy networks that were built years ago that have been integrated. Mm-hmm. Sometimes not so integrated. Mm-hmm. And so you come into a metro, you see a lot of lines on a map, but the actual quality of the asset does not serve the purpose of largest consumers of bandwidth, which is who we serve.
Right.
So most of what we do is build networks that are purpose-built, that are homogeneous, and that connect data centers. And I use data centers kind of loosely. It's centers of compute.
Right.
And that can be single-tenant data centers for a hyperscaler, a campus. That can be multi-tenant data centers, a carrier hotel, an IP POP. That's what we're focused on, because that's where obviously we see most of the data coming and going. But what our customers need is something that's scalable and low loss and low latency. Because you may have a line on a map that goes from one data center to the other data center, and you may look at that and say, okay, yeah, I'll take a pair of fiber between those two data centers. But actually, it doesn't route that way. It goes back around, goes through a CEO, splices through somebody's living room. I'm
going to pause you for a second. Yeah. We love our acronyms. I'm an ex-military guy. I love my military, and we're in digital infrastructure. We love our acronyms. So when you say a CO, what's a CO for people?
Central office, just an old telecom.
That's an older telecom, everything else you talked, even POP, people would probably know that. But a CO is what? Just like a little regional?
Just a regional. It's an old carrier POP where you'd have maybe an old telephone company that everything met and all the switches existed. So you could go from one network to the next and move it on down the line.
Right. For those who aren't from the 90s, they don't remember, or even early 2000s, they don't remember the really early Mindspring and You've Got Mail folks and whatever that had the internet pops, which are where there was no video, but you would have these connecting points. So, and before that was, of course, the telephone offices, which is why they call them COs.
So in the markets where we serve, they're building a lot of data centers, or a lot of data centers exist.
Right.
Either the data center operators or the customer, the tenants that take up space in those data centers, they've got a set of requirements for connectivity, right? There's certain specifications that they have to have, or they don't. Their internal customers are very unhappy with them.
Which is us.
Yeah,
which are just people.
Exactly.
Right.
And so I think we came in and saw a deficiency, just sort of a gap in the market, and that's what we've tried to solve. We have customers that they require 4 routes, four unique paths from one data center to another one of their sites. And there's certain thresholds that indicate, hey, I need 2 routes, 3 routes, or 4 routes. But 4 all underground routes with high count fiber in a metro, that doesn't exist really.
Right.
And so when the folks that founded our company, they kind of came in and they've got great relationships with some of the big hyperscalers, and that's what they're being told is like, hey, we need somebody to come in and completely change the market from a fiber perspective, because we've got all these data centers. We're building these other data centers. We're trying to scale in this market, and we're working with the usual suspects and the incumbents, and they don't have it. They'd have to build it, and some of them don't want to spend the capital, or some of them, either just aren't.
They're not prepared for it.
They're not willing to release the asset.
Right.
And so they looked at us and said, "Can you just come build a new network in this metro that actually solves the problem that we face, given the amount of compute that we have in this metro?" And so that's where we fit in, and we're seeing it, and it's not just the markets that we're in, but a lot of markets. And I mean, I think with AI and ML, I mean, we could talk all day about that, but that's driving obviously a massive amount of lease up and development in the data center world, right? And those data centers have very similar requirements. And those data centers are popping up in areas where there's traditionally not a lot of new fiber, because it's hard to find 100 megawatts downtown. Right. Right.
Yeah.
And so that's another thing that we've spent kind of another part of the industry that we're focusing very heavily on, because we're getting requests to go to places you typically don't need to build 4 routes with a 1728, in each route.
Right.
So
that's a great point. I'm really curious. So to me, first of all, let me ask 2 questions, and you answer them in whatever order you want.
Yeah.
When you talk about a metropolitan area in your mind, so you're with an organization called Bandwidth IG, and while we're going to mostly be talking about the industry, we're going to also hone in on how you guys. I love it when somebody comes and says, I need a problem for growth industry, and you can understand how to solve it, and so you dive into it. So that's awesome. But anyway, when you think about a metropolitan area, what does that mean from you or your organization's perspective? And the second is, I get lately I've been getting anxious when I hear somebody say something like, because we all have an AI story, as Sarah Keller over at Uber said, we all have an AI story.
Yeah.
But AI is driving, and it feels like when we're talking about large language model or the current generative AI, but whether it's that specifically or just AI in general, there's the training locations. We're building data centers where they might happen, and those tend to be in the locations that you wouldn't have imagined 5 years ago a data center needed to be. They generally weren't in one of the big NFL cities. They certainly weren't in one of the traditional 3 to 5, centers of data, as Phil Lawson-Shanks says on occasion. Yeah. But anyway, so there's a lot of training there. And what I've heard is that they don't need a lot of it's not latency sensitive. It's, and I'm surprised to hear that maybe they need more routes. But anyway, so you're going to correct or affirm my assumption. And then there's the other AI. So that whatever training's done, or in different applications altogether, there's the inference or other things. And that has to happen in a metropolitan area. It doesn't live out somewhere else. It lives really close to eyeballs, generally speaking. And I could see in that instance needing lots of paths, very latency sensitive, that sort of thing. So those are the things that I've heard. Can you define what a metropolitan area is, and then react to those two things about AI or data centers out in the far away versus close?
All the answers to those are so interrelated.
Well, take a shot. It's just living on the internet forever.
Yes. The metropolitan area. Do I define it by a distance, a circumference? Maybe. It's when I consider the metros that are very active in this space, it's tier 1 and tier 2 metros, right? Traditionally, and that's changing, but that's traditionally what it is, and it's within your 50-mile/80 kilometer distance, which is kind of a latency threshold that a lot of people try to stay within.
Right.
When we're talking about AI and how that's impacting it. You're absolutely right. Something that's built purely for training, nothing else. Training. This is machine talking to machine.
Right.
Latency doesn't matter. It doesn't necessarily need to go anywhere. It's just all in-house training.
Right.
Will those data centers and will those types of facilities continue to be built in the middle of that 80 kilometer circumference? Less likely. If it's purely for that purpose and will always be for that purpose, why would you buy expensive real estate and power in the middle of
somewhere
some tier 1 or 2 metro? So put that in a cornfield.
Right.
And I think we'll see that. We'll see a lot of random press releases come out of some hyperscaler bought 400 acres in
Arkansas.
Western Nebraska or Arkansas or something, wherever they can find the power, and that's a part of this. But I don't. You're right. I don't think that fiber connectivity challenge, other than it being remote and they got to do something, it's not like they need 4 routes with big thick count cables coming in from all directions. What my theory, and this comes not just a theory, it comes from a lot of discussions with customers, partners, et cetera, is that when you're taking a lot of power and you're building out your compute centers, it's nice for them to be a little more dynamic than just a training center in a cornfield. Because what if you want to peel off 10 megawatts and put some network gear in there because you're trying to share a lot? You're actually going to do some inference out of that training center with some other location. What if it needs to carve out another 20 megawatts to be part of an availability zone or a local zone or something? So if there is still a huge draw to building these facilities closer to the eyeballs because it's multi-purpose. It's not just you're kind of one and done when you go build 300 megawatts in western Nebraska.
Right. Well, it is Nebraska.
Yeah.
That's what all the people in Kansas tell me.
Where the N stands for knowledge. Oh no, exactly, you're gonna have to edit that.
One
out.
of my best friends is such a Nebraska fan. He's got a Nebraska tree set up in his basement that he never takes down for Christmas. And I was like, you know what? You put it up the last time they were in a national championship run, and you'll probably be there forever because you won't take it down until they win it. It's not going to happen. We're going to leave this in. I don't care. We can poke the bear. Yeah. But anyway.
Yeah. So when I think about how is AI training versus inference impacting where these data centers or influencing where these data centers are built and how they're connected. You're going to have your training centers purpose solely for that reason, but I think the majority of the lease up is not that. It is actually still in the larger metros, but it's going to be more multifaceted.
Yeah. The reason I ask is in the data center design and engineering side,
Yeah.
there is becoming more and more a topic of conversation. Do we still need the same level of redundancy from a design, so not a connectivity, but just a data center operation perspective? Do I still need the same kind of UPS infrastructure? Do I need ride-through other than just spot ride-through for maintenance or something like that?
Yeah.
Do I really need something to carry an entire 100 megawatt, 300 megawatt, 1,000 megawatt load, whatever, because my redundancy doesn't come from 2 or 10 or 1,000 systems in the same suite. Some are in Atlanta, some are in Birmingham, some are in Nashville, whatever. The metro has gone from that 80-kilometer to a 6-city southeast corridor or whatever it is, and 3 of the 5 nodes can serve my customers within a acceptable service level.
Right.
So that way, my data center infrastructure isn't as expensive because I don't need the same amount of capital applied to it. Yep. It's not as complicated. It's easier to deploy. In other words, the application's giving me the resiliency. I still need connectivity, but I don't. I wonder if there's a application there where instead of needing 4 paths, 2 paths are okay because I'm distributing it across 5. That's why I know that maybe we're talking about different applications, but that's it's not being asked for yet.
Yep.
But it's this kind of voice that has come up in the past where eventually it materializes. Some version of that materializes into a design.
Yep. I think it depends entirely on the use case and the application.
Okay.
I think what's common, I think a common thread would be future proofing.
Okay.
I think you're seeing a lot of these types of customers that want that type of infrastructure available to them. If it's not for today, it'll be in 5 years or 3 years or whatever.
Right.
I do think that there are solutions, just like you've described, that kind of solve part of that redundancy problem in different metros. But for whatever reason, and I think there are a lot of them, you're still seeing proximity as a huge driver for growth with individual customers. Like a single customer, it's rare they're going to buy 100 megawatts in one metro and then just kind of be like, we're good there. We're going to go to another metro because essentially with the applications we don't rely on latency is not an issue.
Right.
Once an availability or a local zone is established, there is a huge search for headroom.
Right.
And I think that's just because they want options in terms of what they do with these facilities. It's not a single use case. It's going to be multiple use cases.
Yeah. My chief growth officer, Tag, and I have heard a couple times conversation that has said, I know because we talked about it a while ago, is availability zones. So let's pause. Actually, this is a great place to pause. When you think of an availability zone, I think the phrase was coined by Amazon. Yep. But what in your mind is an availability zone? What does that mean?
Coined by Amazon. I think Oracle uses availability domain. I think Microsoft uses something different.
Something GCP limit.
Uses, I basically consider it just a delivery mechanism for the cloud product.
Okay.
And they wanted it in a region. The availability zone that's common for a lot of the cloud providers up in Northern Virginia have started moving down to Atlanta because of power constraints, right?
Right.
So that availability zone.
Power constraints in Northern Virginia.
Yeah. Got to come down to Atlanta.
Right. It has nothing to do with the 2 out of 3 year national championship Georgia Bulldogs. Sure. Complete coincidence.
But the question around like, what is an availability zone? I guess I'll stop there and say that's what an availability zone is.
I've always thought about it. Maybe it's the same thing. It's at least, to your point, 3 legs of the stool, maybe more, but it's at least 3 legs. They're within a certain physical and fiber distance to each other. They have a certain latency distance to each other. They like them so they will be different physical. It could. They're more willing now to accept that it could be the same data center provider, either themselves or an operator that they partner with, or some combination of that.
That's right.
For the longest time, they wanted them to be 2 if they could make that work. And you're right; it was for cloud services and these really interconnected cloud things. I remember I was talking to person who's become a friend of mine, Tony Grayson, who's over at Compass. I was like, I'm hearing these availability zones are going away. And I didn't know. He laughed at me. I'm glad we were able to edit that out of our conversation because, like you, he is, he's not in the telecom. It just depends on what customer you're talking to. There are a number of, and actually it's not even customer, which group within your customer portfolio, right? Mm-hmm. You'd be talking to a big cloud provider that's also doing training for AI, that's also doing inference and has models that they're rolling out for autonomous vehicle, whatever. Mm-hmm. And depending upon which product, they may or may not need availability zones. But I guess my point is, it seems like their demise has been greatly exaggerated, that it's not only healthy, it's continuing to be important and probably will be for the foreseeable future.
And it's got to be close to the eyeball. It's got to be close to some sort of internet drain. You're right. It's got to go back to in Atlanta, you'd have a 56 Marietta or a 180 Peachtree. In Chicago, it'd be a 350 Cermak. I go on and on.
Right.
Those types of connectivity hubs are still absolutely critical from a proximity and latency standpoint to an availability zone. Like, I don't think you can put an availability zone in western Nebraska. I don't think that works. And I think
eventually, probably, right? Something.
Yeah, but I think you can put a training facility out there, an AI training. And I think that's probably taken a lot of attention away from the traditional availability zones to say, hey, they're building these gigawatt, training or these data center campuses in Iowa and Nebraska, North Dakota. I guess availability zones don't matter anymore. I don't know if there's some correlation there.
Yeah. But maybe. I don't know. Let me ask you this. We didn't talk about this beforehand, and if we don't need to go down that road, but here in Atlanta, I got 3 or 4 carrier hotels, really 2, but I got 3 or 4 sort of nodes. All major metropolitan areas, certainly the cloud hubs. Atlanta is not yet a cloud hub, but it's growing in importance.
Sure.
It's certainly a data center, super important. I would argue, like I did with Sam Prudhomme, that it is another Austin person, that it is. And but one of the things that we do when we design, you do it in fiber. You're looking to remove single points of failure, and the single point of failure. Sometimes you'll say, "Well, look, I got 2 computers. Yeah, but they're in the same rack." Or I got 2 racks. Yeah, but they're hanging off the same PDU or whatever. Do you think there's a time coming where we're going to introduce more, for lack of a better word, carrier hotel or connectivity hubs where it might not be downtown Atlanta? Absolutely. It might be in the suburbs, so that I can't, if there's a cataclysmic event in the middle of some metropolitan area, I'm not bringing down 60% of the traffic in North America because I just took out a big building or 2 in Northern Virginia or Chicago or Dallas or Atlanta or whatever.
Without question. Yeah. Without question. Not only is there a single point of failure kind of risk, there is its cost, its congestion. It's hard for some of the larger customers when they want to put network gear, when they want to pop some of those carrier hotels. They can't scale. They can't do it the way they want to do it. There's just not enough power there, or it's too expensive, or exactly. So I think we'll start to see these kind of connectivity hubs begin to spring up not only in Tier 1 metros in the suburbs, but in Tier 2 and Tier 3 metros. I think we'll start to see it as well.
Yeah. Well, we're seeing it within our buildings. Like there, I don't know that I would call them that yet, but they are for sure building out nodes. I don't know if we can extrapolate that to where they will, there will be this homogeneous, sharing. And I mean, one of the things when we talk about a node like in downtown Atlanta, it's open to anybody. If you can find space, you can come in and you can interconnect with your neighbor and all these other things. So
you have to bring a lot of connectivity into those buildings to make them relevant, and that's the biggest challenge. Yeah, is getting everybody to come to you. Why are you going to do that? And it usually requires getting one of the big guys to go in on it with you and say, "Hey, everyone, come here." Right. Yes, the 56s and the 350 Cermax and those locations are never going away. They're going to be extraordinarily relevant, but there needs to be an alternative. But in order for that to work, I think you have to have anchor is a bad word, but you have to have
an anchor tenant,
some anchor to draw all that connectivity to you to build that ecosystem. Yeah. But it's a huge need. I talked to a lot of the network leaders at the hyperscale with our hyperscale customers, and they all say that's a problem. It's just congestion. They can't grow. They can't scale.
And it's expensive.
It's really expensive.
Really expensive. Yeah. I just a while ago I was at PTC, and I was just able to listen to. Just happened to catch. I think it's your CEO, Bruce. Is that correct? Bruce, he was interviewed by JSA. It was a great conversation. And he was talking about a program. I think it's related to this. I didn't tell you about this ahead of time. So here you go. It just popped out of my brain. But they just finished. You guys are finishing or in the process of finishing a project in the Bay Area, one of the most congested but demanding and needing a solution areas, certainly in the U.S., if not the world.
That's right.
Can you tell us about that project?
I would love to. It's classic example that touches on just about every theme we've hit in terms of why we're building new networks and why they're required. That market is, from a fiber perspective, I'll call it single-threaded. There's just not a lot of options, and it's been the same option for many numbers of years. It is the second largest data center market, I think, behind Ashburn.
Is it? It's got to be, right? May West, yeah.
I mean, it's a huge data center market. They aren't building as many new ones because of the power constraints and land availability, but it is a robust data center market. Right. And the problem statement is what we've been discussing all along. You have hundreds and hundreds of megawatts. You have availability zones, availability domains, whatever you want to call them, that exist in that market that are expanding rapidly that need a completely different solution from a connectivity standpoint. The scale requirements for actual pairs of fiber was off the charts. The sheer need for diversity from incumbent networks was just a massive pain point. Outages and all sorts of things impacting the quality of the service. So these customers said we need something completely different in the market. So Bandwidth IG came in about 3.5 years ago and began to overbuild San Francisco, the Bay Area, I should say. I think if you fast forward today, we have over 200 miles of new kind of underground network, diverse from the incumbents, connecting all of the centers of compute within that market. 100% underground, largely diverse from existing networks, all built within the last 3 years. Homogeneous fiber, and that's the criteria. And so we built that network. It was purpose built truly for a couple of customers, but we built a lot more than what those customers were asking for, just because we felt the market needed an alternative. But we built all of it, even that of which was not for those customers, to their specifications. So every inch of our network is built off of a hyperscale spec sheet, basically, what they would require. And then now that is available in the market, which we think was a huge gap in that market, given how congested it is and given how much digital commerce is just going on in that market in all areas. The last thing I'll say, which is super important, is east to west diversity. Right, you have the peninsula up to the city, and then you've got the East Bay with everything going on in the East Bay. Really only a couple of bridges.
So when you say East Bay, that's Oakland or
down, San Leandro and all the way down.
Hayward or whatever, all over there.
Yeah. The only connectivity east to west goes across a couple of bridges, and similar to our conversations earlier, tapped out, not a lot of inventory. I wouldn't say it's the most reliable network on the planet just because it's been there a long time and it goes over congested bridgeway.
Right.
We built the first marine cable to go below the bay to cross from basically South San Francisco over to San Leandro. And so it's a brand new diverse route that we placed it on the bay floor, jetted it beneath the silt, and provides a completely unique path to get from the east side of the bay to the west side of the bay, something that hadn't been done in 20 plus years, I think.
That's incredible.
Yeah.
I can't even imagine, because I know how we've built data centers in the Bay Area, and it's like the actual building of the data center has its complexities because of the topography of that part of the world.
Yeah.
But just negotiating through all the municipalities and all of the paperwork is a art form, and it requires the patience of Job to get through. I can't even imagine the scale beyond the engineering requirements of the lift to make that happen.
I wish I could even tell you how many hundreds, if not thousands, of permits that were required to do that. And if Andy Munn, who's our head of construction, was in here, you would see just like you wouldn't know it. He is as the definition of Cool Hand Luke. Like, he's so steady Eddie.
Right.
He has faced just his tolerance for just illogical, people,
right,
and everything that he's had to deal with to get through all of these permits is Herculean.
Right.
But yeah, no shortage of challenges to get that network built, and even the subsea part was tough. But even the terrestrial, I mean, it's an entirely different conversation about how difficult it can be to find right of way to build in the public right of way in a congested city,
right,
and in a city with a lot of restrictions as to what you can do with public property, public right of way.
Right. It's and I know you think the exact same way, and I'm sure your construction leader does as well. To the group that you're talking to, these things make sense. Like, here's why. This makes sense. Either something happened before or we heard about something somewhere else. And so to try to bulldoze through or whatever, it's not going to work. You've got to work alongside them. And, you can't just be calm. And I'm sure he's a master at this as well. How do I understand what we're trying to solve? How do I accommodate that? Without impacting the design of what we're trying to deploy? If we deploy something that's doesn't solve a problem, well, that's not worth doing. And we have to do it within these constraints. But it also illustrates, if that's this unique area, and now I want to extend from there beyond the metro, up and down the coast of California, for example, from the Oregon border all the way down to the Mexican border, and all those communities through there with their own unique things, and so more of a middle or long pull. It just illustrates, I think, exponentially. Same thing with power. Many times they can solve for it's just time. They can solve for building a power plant generation, but to get it to where it needs to be is not only much more complicated today in terms of the regulation, but it's so expensive. Without just navigating, right?
Yep. In the case of San Francisco, we had a deliverable, right, that we'd committed to, and we just had to find a way to do it.
Right.
In many cases, we'll be building, and so that was a whole unique and very special challenge to do exactly what we'd promised the customer we would do. To that specification. In other markets, and that's kind of the problem with the fiber markets that exist today, is a lot of times it's just path of least resistance. Just get it done as inexpensively and as quickly as possible.
Right.
Well, for us to go into another metro like Atlanta, like we did, we initially built out our first part of Atlanta on spec. We didn't do it based on a contract with the customer. It was speculative, but we knew that the only way that network would be of any real value would be to do it the same way we did it in San Francisco. Because that's when the customers actually come to us and say, what do you have? And you show lines on a map that are exactly the same as the incumbent's lines on the map, and it's built the exact same way. They're going to say, well, that's just that doesn't solve our problem. I'm glad to know that you exist, but for the particular use case, we need we need a network that looks like this. And so I think it's tempting to, when you're expanding a fiber network, to do it as inexpensively and as quickly as possible. But I think providers that are doing that will find that you're just sort of layering on to the existing set of capabilities in a market that the customers aren't looking for that. They're looking for something different.
Right. Is it, and this is where your engineers are going to disconnect and delete this podcast, but is it as simple as when you bring a new solution to a marketplace, to a metropolitan area, is it as simple as, or the special sauce is, it's these 2 to 4 diverse paths. It's very few, it's really clean paths. It is, it's using brand new glass. So the product that's going in the ground is clean. The paths are diverse, and we bring a level of diversity there, and you don't have a bunch of cuts or breaks. Or is there also, what am I trying to say? Quality, I guess. So if I'm relating it to a data center, we make them bigger. We make them spectacularly more efficient, but we're also changing the designs. We've worked, the way we use water has completely changed. We don't, none of our designs consume water anymore.
Right.
They may use it in a closed system, but we're not designed to lose water. The efficiency of the gear that we have, the technology that we have on it, so that we can have AI assistance. If I'm making 1 million square foot into a 3 or 4 million square foot facility with hundreds, if not thousands of megawatts, and I've got thousands upon thousands of valves and actuators and components in there, the human element hasn't grown by the same scale, but the technology has joined me so that I have a much better real-time control of my environment. Is that also coming along, these tools and the ability to manage the network, or other design features? Or is it as simple, and I don't mean to say it's simple, diverse paths that are clean and new is really the lion's share of the new thing we're bringing to a market?
That piece is critical, and that's probably the hardest part, is getting that accomplished. What we're seeing a lot of innovation is just the form factor of these cables that are going into the ground.
Okay.
And that's really important, because you have a lot of jurisdictions that, without any exceptions, they will limit the size of the conduit that you can put. They'll limit the size of a bore that you can put through the ground. And so if you've only got one shot to do one bore, and you don't want to go back and reapply and continue to dig up the streets or have to dig up the other side of the street,
right,
how many fibers can you actually fit into that bore? And it used to be that you'd pull a 144, like I said earlier, through a 2-inch conduit or an inch and a quarter. Now we pull 17/28 through an 1.25 inch conduit, and that really matters. That's a huge difference.
Right.
They have these different technologies now where you can microduct these conduits and pull like a 6912 through basically a 2-inch conduit. Don't quote me exactly, but just huge amounts of capacity in much smaller form factors. That enables us to do a lot more with a lot less when it comes to securing right-of-way and the limitations that we face in the right-of-way.
Right.
So we're always turning to our vendors on the fiber side, on the supply side, and saying, can we get 6912 in a 2-inch conduit? Like what kind of microduct package can we do that would fit through that? And they'll work with us. The Bay Crossing, they literally invented that cable. There's never been a 1728 that they've put underwater. It's usually those super thin counts, and you got to put the really expensive appliances on either end to shoot terabits across. Right. Since it was shorter distance, that wasn't an issue. We needed more fiber, and then Prismia literally invented this like crazy 1728 cable that was suitable for marine application. Right. So it's things like that I think we're seeing that are pretty innovative, just to do more with less.
Isn't it incredible just to see? Only us nerds can get excited about this, but that they can to put things in with this spectacular capacity, with this unbelievable efficiency, in these amazing small spaces, like the engineering, the design, the imagination. My experience with this the other day was we heard that AT&T fiber is coming to our neighborhood. Yeah. And I know friends not far away. We live up by the lake, not far from here. And they're you're like, this is unbelievable. Like, this is just, I'm sure it's like DSL in 1998 or whatever it was. Like, it's just unbelievable. Can't believe it. Well, they came into my neighborhood. It's not yet ready to go from the box to the house. And Patton, I thought it was going to take 6 weeks of digging up, and we're not a big neighborhood, but we're an old neighborhood, so big, 1/2 acre to 2 acre, not big houses, but really big lots, and they've been there forever with lots of big trees and whatever. 2 days, maybe they blew through 80 houses.
Just bam, bam, bam.
I could not believe. I didn't know the technology they were using, but they just ran. They had like a group of guys. I mean, almost as fast as you could feed. Nobody's driveway got dug up. Nothing. They just came through in the easement area and just blew it in. And they came back the other day and put the boxes every house or two or whatever it was. And next stage, I was like, is there more to it? Yeah. No, that's it. Day and a half, 2 days, at most 3 days, because I wasn't in the neighborhood the whole time. Yeah. But I couldn't even imagine or comprehend the speed. And it wasn't a big mess.
Yeah.
What I thought was going to happen.
Well, imagine them doing that hundreds of thousands of times across 10 other companies all over the country. I like to think about it. What that triggers in my mind is just think of all those. Now everyone has a gig. And what are you going to do with that? You're just going to push more and demand more. So you're just going to have all these tributaries of one gig households coming into these communities that then need more middle mile and more long haul and more backbone. So our contribution to that is just build bigger cables in the core, because all that's going to have to come to the core and have to get around between data centers. And that's one of the reasons we exist, is we just continue to see that happen. My
phrase, I used this at PTC in my talk, was the more we use, the more we want. The more we want, the more we make. The more we make, the more we use, right? 8K TVs, there's going to be a time down the road, it's going to be like, I remember before we used quantum television, and it was, it wasn't 32K, and it was, whatever. My kid saw a picture the other day of us with a old traditional television sitting on the TV stand. Remember, you had the big TV stand. That's probably way before your time. You had the big TV stand. It had the big 32-inch TV. Well, we thought was a big 32-inch TV back then. And my kids were kind of standing right next to it. They're like, if this thing fell on us, oh yeah, you'd be dead. But back then, we were hardier, tougher people 20 years ago. You'd have died. I remember my first 21-inch computer monitor that I think my table bowed in on, and you could get a suntan if you watched a desert movie. Yeah, you can throw a 48-inch flat screen like a Frisbee. Yeah. Nowadays it's totally insane. It's insane. Yeah. So, look, it's there's plenty of comments about the challenges with the digital infrastructure that we're building, and whether it's the actual building it out or we're using the data the right way. But I think the opportunity lends itself to human flourishing. Yep. And as far as I'm concerned, you've got to bring an ethic along with it. But we're not going to stop innovating. We're not going to stop using. So no, and I think one of the things we touched on much earlier that is worth reiterating, as this growth continues, which it will, it's just not going to stop. There's nothing. It is a rising tide. We will see data centers innovate and evolve. Mm-hmm. We will see the fiber networks continue to grow. But as these data centers, we're shocked at how at the rate at which we're seeing them built, mm-hmm. Which is a whole other conversation. Mm-hmm. But as that occurs, it's spreading outside of the metros, and it's getting to a point where, as these things are being constructed, this concept that fiber is fungible, mm-hmm. It doesn't really apply anymore, and that's a really important point, I think. Yeah, what do you mean by that? For people to get their head around it. Well, it was always that go build a data center, find the land, find the power, and the fiber will just be there. Right. What we're seeing is, and we're getting some somewhat frantic phone calls from certain customers, is that they're down the road on their zoning, they're down the road on construction, they've got power, right? And all of a sudden, their tenants are saying, "Where's the fiber?" Right. And they're saying, "Oh, well, we've got this route from this incumbent or this old telephone company's got a line here," and they're like, "Nope, that's not going to work. Right. You got to come up with something different, and you got to come up with it quick." Right. Fiber is maybe not so fungible if you're building, 20 miles outside of town,
and you're putting 300 or 400 megawatts in
Right.
the ground, and you have these customers that are used to a certain asset being available to them, you got to go build that.
Right.
It doesn't exist. And Atlanta's a perfect example of that. One you're very familiar with south of town here in Fayetteville was a great example actually of the data center operator pre-planning and actually being prepared for this. We built 2 routes that just didn't exist because the customer said, "What these lines that are on the map today will not cut it. That will not work for our applications. We've got to get something new down here." And we're seeing examples of that in other metros as well, where we exist and where we don't yet exist.
Yeah.
So that's all I'll say about that. But it's an interesting, I think, change in the game that is unfolding kind of right before our eyes.
I think so too. It is. Speaking about my organization, we're very fortunate that in the connectivity side of my house, I have people that are very seasoned in from a telecom perspective. They're fiber people as well as data center people. Many times you have one or the other.
Right.
And these folks have been in the crucible of fire as we've grown up and experienced not enough options before. It now is part of, it's not the only area of engineering and planning for a campus or a facility. Any of our frenemies, many of them are bringing that kind of skill and that kind of perspective to the conversation as well. Not all executives will listen to them, but if they, at their peril, they don't. Fortunately, our executive leadership pays a lot of attention to these conversations. Yeah. And we've got a healthy mix of people that come from the telecom world and have grown up in the data center world and how these things interplay. Yeah. And we came out of the IT service business. Yeah. And so we learned that if you don't have a healthy story around compute, storage, and network, you can build an amazing storage and compute. But when you go to do backup and it takes your whole environment down because you didn't plan the right network and you didn't communicate and you didn't see down the road the growth pattern, we've learned through those things. Sometimes it's a bad day, very painfully. Yeah. And, if you don't have capacity in your overhead or whatever, it's all applicable just on a different scale. And so those organizations, and there are a number of them that are sophisticated and are trying to think out loud and think ahead of time. And a lot of our engineers are in communities that share this information. They don't share the secret sauce, but they share the pain points sort of at the trade level, and they get thinking about it. What's as interesting as that is to me, that you got to have that level of sophistication, and it'll work itself out. Those people that don't continue with that level of sophistication and vision, they just won't be around for long. Yep. But the other is, there are some components that get a lot of attention. And to your point about fungible, the telecommunication piece just hadn't gotten attention. And in my mind, it is every bit as challenging as the power and the mechanical or the plumbing piece, the cooling piece that we're having to solve. Is this third leg of the stool. Mm-hmm. And if you don't have that solved in the future, at least to plan, who are my partners, what's the supply look like, how would we do this? You could have solved for these other two, but you'll be stuck on this one. Mm-hmm. And not just the marketplace, but our industry needs to make sure they're thinking about it.
That's right. And it's the customers that are going to be the ones demanding specifically what that looks like. And that's where I think some of the operators can get caught off guard, is they think they actually have solved for that.
Right.
And then they're courting a customer who wants something completely different.
Right.
So it's definitely worth getting way out ahead of, because it can surprise you as to how robust some of these demands are by some of these consumers.
Well, we talked about a lot today, and it was all super nerd stuff. So thank you. We got to make fun of Nebraska football, which makes me feel good. Go Big Red. Look, if people want to learn more about you or Bandwidth IG and what you guys are up to, how can they do that?
You can visit our website at bandwidthig.com.
All right.
You can call me directly.
All right. Are you on there? We'll put your LinkedIn connection and your website and other in the show notes.
Come to the LinkedIn page. We're regulars at the, out at PTC, ITW.
Right. Big industry events.
Big industry events. We usually visit NANOGs. the wholesale carrier business is actually a big part of our customer base because they too turn to us to say, wow, we need something new as well.
Right.
A lot of our frenemies won't sell us dark fiber, or what we have is not unique to them.
Right.
So we do a lot with in the kind of the wholesale carrier conferences. They're important partners to us. We'd love to talk to those interested in this subject, and thank you for having me.
My great pleasure.
Yeah.
Hey, if you guys enjoyed the conversation, like it, and if you loved it, subscribe. We'll see you next time, everybody. Have a good one.